For diagram A, it says object O is outside the focal point and the image I is real. So for A, have a look at the object. It's on the left of F1, where F1 is also the focus and F2 is the other focus. And you got rays 1, 2, and 3. So the ray 1 is parallel to the x-axis. It hits the convex lens and then it goes through the focus F2. The ray 2 is from the top of the object going straight into the lens, a straight diagonal line, and then intersects the line, the purple line, after the lens. And then line 3 is where the line coming from the top of the object going through the focus F1 that hits the lens, and then it goes into a straight line parallel to the principal axis. So here the object O is outside the focal point, so it's the left of F1, and the image I is real because it's formed by the light rays, and all three rays are intersecting, and that is where the image is formed. For image B, it is similar to image A, but it is a lot closer to the focal point. And in this case, the image I is real, but it is just further away from F2. C, the object is even closer. Again, the image is real, but it is just even further away. So the image distance is longer than the object distance. Now what happens at D? So the image D is when the object O is at the focal point, and that is where the image is at infinity. So if you look at the purple lines and the green lines, they're parallel, and it is, well, they don't meet, so therefore it is at infinity. And if you look at E, the object O is inside the focal point. So if the distance between the focus and the lens is longer than the object distance, so here where it says object O is inside the focal point, then the image I is virtual and it is larger than the object. So if you were to trace back the light rays, then they will meet at a single point, and that is where the image, the virtual image, is formed, the dotted line. All right, so let's see if you can answer these questions then. So where is the image located? What number is it? What does a converging lens do? Is the image distance longer than the focal length? What does a diverging lens do? Where is the principal focus? All right, so the answers are the image is located at the point where the two rays meet at 3. So have a look at ray 1, where it is just a straight diagonal line from the top of the object. It goes through the lens and it meets at 3. And have a look at the parallel ray 2 to the x-axis. After the ray 2 meets the lens, it goes down through the focus, and that is where it meets at 3. A converging lens will produce a real image of an object where it is found at a distance greater than the focal length from the lens. So look at the distance from the real image and the lens. That is longer than the distance of that dot to that lens, and that dot is the focal length. So it is at a distance greater. The second part, a diverging lens will make parallel rays to spread out or diverge from a point. And if you trace back the rays, you can see that it has a focus, and that is where the rays diverge from. And that is called the principal focus. That is to the left of the diverging lens. All right, let's have a look at these questions. Where is the image found? Describe 3 things about the image formed. What is the focal length? As in, what is the description of the focal length? All right, so the answers are the image is found at the point where the two rays meet. The image is virtual, enlarged, and upright. So here, can you see this is the negative type? So where is this the negative type? You've got the virtual image. So the image is formed to the left of the object. That's why it's negative. Now, if you look at the virtual image, it is a lot larger, bigger, it is enlarged, it is upright, meaning it is if it was inverted, it will be in the opposite direction, and it is virtual. So those are your 3 descriptions. And the focal length is where the distance of the principal focus from the lens. So if you look at the distance from the lens, so the lens is that orange curly ellipse thingy, the lens, and it's the distance from the focus to the lens. So that is the focal length. It's the pink line. So the pink line is where it says the distance of the principal focus to the lens or from the lens. This depends on how curved the lens is. The shorter the focal length, the more curved it is. Equally, if you have a short focal length, it is more power. So the greater the power of the lens, the shorter the focal length, because it just means that if the distance is shorter, it means that it is able to focus. So if it's more powerful, then it can focus at a shorter distance. If it was at a longer distance, it is less powerful, it is weak. All right, so here you have a list of 4 instruments, optical instruments that uses convex lens. So for a magnifying glass, a virtual image will be formed, it is magnified and it is upright. For eye or camera, it is real, smaller and inverted. So you know, in the eye, the image is formed at the back of the retina, on the retina, and it is inverted. It will be smaller, but it is real. If you use a projector, it'll be a real image and it'll be magnified and it'll be inverted. And if you use a microscope or a telescope, it will be real, inverted. This is in the middle of the optical instrument. And then when you're looking at it, it'll be virtual and upright. Okay, so have a look at these 4 diagrams. On the top left, you've got a magnifying glass. And can you see that this is the negative type? So the image is to the left of the object, and you can see that it is a lot bigger. It is virtual because you have to trace back the light rays. It is magnified, upright and virtual. So this is for magnifying glass. If you look at the eye, so again, in the eye, you've got a convex lens. So if you look at the giraffe, you see the object. Now at the focal point, that is where it is 0. But then can you see that the image is now inverted, meaning now it has swapped. So if you look at the top line from the object, it goes into the convex lens, it goes down diagonally. And so now the top of the object becomes at the bottom, and the bottom of the object, as it goes through the convex lens, it goes to the top. So therefore, the eye uses a convex lens, it is inverted and it is real and smaller. Have a look at the projector. Now for the projector, it uses a convex lens. In this case, it is magnified, it is inverted and it is real. So have a look at the slide in the middle of the diagram where the arrow is pointing down. And then can you see that the lines have swapped after it passes through the convex lens? So now it is inverted compared to the original image. It is real because the light rays are tracing it. You don't have to trace back. And it is okay, so it's magnified, inverted and real. If you look at the telescope, can you see inside the middle of the diagram, you've got the objective and eyepiece focus. So for that focus, it is real and inverted. And then if you look at the eyepiece where there's another convex lens, it will be virtual because you have to trace the light back and it will be upright. These are ray diagrams for the projector and for the magnifying glass. So again, the magnifying glass is just the negative type where the image is formed to the left of the object, so that's why it's negative. And if you look at the projector at the top of the diagram, this is where the image is inverted. It is real, so it is inverted, real, and it would be magnified.